Welcome to qnawire.
Hi, so over here we have two different questions. For the first one, we are provided the pH for a unknown solution. We're told that the value is 7.14, and we want to know the concentration of H plus. So the concentration of H plus, it is going to be equal to 10 to the minus pH, and this is going to be 10 to the minus 7.14. That that it is going to be equal to 7.244 times 10 to the minus 8. And this is going to be in mole per liter. And of course, moles of H plus ions. Okay. At the same time, in this question, we know a different solution that contains 10 moles of OH minus per liter. Okay. This means that the concentration of OH minus, it is going to be equal to 10 mole per liter. We can calculate the pOH, that is minus the logarithm of the concentration of OH minus, and this is equal to minus logarithm of 10 to the 1. So the result is minus 1. So using the relationship in between pH and pOH that needs to be equal to 14 because that is the dissociation constant in water, we know that the value for pH would be 14 minus pH, in this case, 14 minus 1. So a pH equal to 15. A very, very alkaline solution, as the problem states. And now for the next question that is provided, we are given that we have 0.2 moles of HCl that are going to be combined with 0.01 mole of potassium hydroxide. So we're going to have the following reaction: HCl plus potassium hydroxide, both of these guys in aqueous medium, are going to produce water as a liquid plus KCl in aqueous medium. Of course, here we're going to have the ions. So we can do our ice table. The limiting reagent, it is going to be, since we have a one-to-one reaction, it is going to be the potassium hydroxide. This ice table is all in mole directly. So the amount of change is minus 0.01, minus 0.01. Here, water, it really doesn't matter because since it is a pure substance in a condensed phase, then it doesn't enter into any equilibrium calculations. So at equilibrium, we're going to end up with 0.01 mole of HCl, something close to 0 or 0 of KOH, and 0.01 of the associated salt that we get in solution. We can write down that, of course, we're going to have an extra of 0.01 moles of water, but at the end, it's not that relevant. Okay, so we know that all of this is contained in 1 liter of solution, so the concentration of HCl, remember that HCl, when it comes into contact with water, it dissociates completely, so we can go ahead and write it down as the same as the concentration as H plus, and it's going to be 0.01 divided by 1 liter. Okay, this is equal to 10 to the minus 2. So the pH, this is minus the logarithm of H plus, is minus the logarithm of 10 to the minus 2. It's going to be equal to 2. And that would be all for this problem. Thank you very much.